So hello guys, thank you Cindy, thank you Cindy for this, and let me share my screen, and uh, guys, welcome to today's TSCC webinar, and today we are going to learn some container stuff, which is about the singularity. So as you might heard this name, Singularity. This container technology is for you to creating and running containers for the HPC clusters. So once you learn it how to use it today, I think you can install every open source software and run them on the HPC clusters, including the TSCC. And also you will become HPC software expert in your lab. So you can help your lab members with software installation issues or some with the container on HPC and including the TSCC. And you can I'd say that you can even don't need our HPC staff to install any software for you if you learn how this container technology works. So why we need Singularity? So I see that most of you are HPC users, or I know your names, and I know most of you are TSCC users. So on a typical supercomputer cluster like TSCC, you may have noticed that you cannot use some system-wide command like yum or apt-get to install some software or some even some very basic system libraries, because you don't have sudo permission, so you cannot use yum or some other tools to install software. Also, you will find that you cannot update system libraries such as the glibc, because also you don't have a sudo privilege. And you'll find that those system libraries are installed in somewhere that you don't have permission to change them. And also on a HPC environment, you cannot easily share your workflow with your colleagues to let them reproduce your test results, because each user usually they have their very unique user environment on the HPC clusters. So you find that you can install a software in your home directory and run some tests and get some results. But if you want your colleagues to reproduce your results, you need to make sure that your colleague also have the same user environment to install that software, or if or run the same test as you did in your own space. And that might be some problems to share and reproduce your results. Of course, you can reach out to us. I mean, reach out to the HPC staff, asking us to install some software for you, either in your own space or system widely. But can HPC staff really help you to install a software with yum, or can help you update some system libraries for you, only because you need those stuff updated? And the answer generally is no. I'm very sorry that we usually cannot help you install software with yum, or we cannot help you update the system libraries either. Why? Because updating those software or libraries may affect other software that already installed system widely. So we can we cannot simply meet your requirement up and you use Yum to update those stuff. So that's the need. That's why we might need a tool to meet your requirement. So we understand that you may need a tool that can help you make the software installation much easier, because you wish to use Yum, and also you wish to update those system libraries for your software, and you also want to want some tool that can help you share your software or share your test result environment to your colleagues. And if possible, you can do it by yourself. You don't need you don't need HPC staff help to install the software on the cluster. And of course, the last thing I list here is you still want to run the software, but you with some containers, but you don't want any performance loss on the cluster. You still want your software can run as fast as it can. Okay, so that's why we need Singularity. So Singularity is an excellent tool to achieve the goals above. And so how this works, how a container like Singularity works. So let's review the Linux system architecture. So we all have a hardware, or we call hardware layer on a cluster, or on a PC. And when your PC or on the cluster is running Linux operating system, we will always have a kernel above the hardware layer. That kernel is for you to make sure that every hardware is power up and can run, and we call this a Linux kernel. And above this Linux kernel, we have a file system to decide where those files and softwares are saved or are stored. And once we decide, we have our file system, we then put our applications into that file systems, and we have lots of applications, including the software and the system libraries and executables and every tools we might need on the cluster. Okay, so now we have a container. Container is used as used for packaging up those applications. So we still have our file system, and we install a container software, or what we call a container launcher. And once we launch a container, we will have some structure like this. So this is a container, has its own container file systems, and that means it has its own data structures, and then we install the applications we want into that container based on the container's file system. So we have a separate file system, and we then install the applications into the container. So that's the idea how the container works. Okay, so how about a Singularity container? Singularity container is a software providing the container technology for the HPC. And as you might have noticed, when you search container, the first result comes to your search output is it's called a Docker. The Docker container is the most popular container in the maybe currently the most popular container in the world. But the thing is, the Docker container is not designed for using on the for the HPC, because inside the container, you can have a root permissions in it. So you can use sudo, and you have a root in the container, which is not allowed in a HPC environment. So that's why we choose Singularity as our HPC container. So in the HPC container, so in the Singularity container, you don't have a root permission. So you can just use the container as a HPC user. Okay, so without the root, Singularity will be more safe and secure in the eyes of our HPC admins. So we let you run the containers, and we don't need to worry that you will have a sudo permission to run something that we don't allow you to do. Besides the security reasons, Singularity is very useful for the HPC because it has it can support some popular HPC features like I listed here. It can support the HPC InfiniBand, and it can support the NVIDIA GPU cards and the MPI, and with Singularity, you can transport and share your software as a single container image. So we will see what is this image later, and you can use that image to produce some results and share it with your colleague. And your colleague can then use that image to reproduce your results. So make these things easy to share and reproduce. And also Singularity can be integrated with the popular job managers such as Slurm. So if your cluster comes with Slurm, the Singularity can be integrated with Slurm. Okay, so here is a short summary why we use Singularity. So without Singularity or without a container tool, you cannot use Yum to install some base softwares, and hence you cannot use Yum to install any softwares actually. But now with Singularity, you can use Yum install, or even you can get some image from the software developers. If the software developer already build a container image for that software, and before you cannot update any seasonal libraries such as the glibc for your application. But now, since the Singularity container has its own file systems, so you can build an image with a newer and preferred Linux distribution. So in that file system, you are free to update any system libraries. You are even free to choose which Linux distribution you want. And before, you cannot share workflow with colleagues to let them reproduce your test results. Now you can just share your image to your colleagues and ask them run on the cluster, and it's very likely that they are able to run it and got the same result as your test. Okay, so we have heard the container image a few times. So what is an image? So a container image is a static file that includes the executable codes, and also it includes any dependencies and the data sets that can for you to to run your software and help you repeat your results. So inside a container image, once it's built, you can it's portable. That means you can share your image to others. It's very easy to share because it's a single file. It's just a file, and it's immutable. That means once it's created, you cannot change or modify the current image. So you can make sure that this is the one you have. You don't need to worry about that. You don't need to worry about that. It will be modified. Okay, so I make an analogy here. So you can imagine a container image is like a game CD. So once you have the game CD, it's there. So you cannot change the what's inside the game CD. You can just share this CD to other players who is using the same game console. So they can play the same game with you as you. Okay, so since we know we need to build a container image, so where should we build it? And generally speaking, the Singularity container image cannot be created on a supercomputer clusters without the root permissions. So it cannot be created on the SDSC clusters like TACC or HSpace, because on those clusters you don't have root permission to build and create a container image. But I heard that some other clusters may allow users to create image even without the root permission. And if you are using other clusters, so please consult their staff to confirm this. Okay, so we cannot build the image on the cluster. So where can we build them? So usually the image can be created on your PC or on some local server where you have the root permission. So as long as you can run sudo command, I think you have a root permission, and you can try building the image there. Also, some Singularity cloud platforms also provide this service to for you to build the Singularity image, but it's just my recommendation that those cloud platforms are very easy to use. Yes, you can just open them in your web browser and begin to build. But I prefer to use I just prefer to use my PC to create those images, so I can easily modify how to build the image, or I can have easier control to access those stuff I have. So that's just my personal preference. Okay, so if we want to install those images on the PC, first thing we have to install them. We have to install the Singularity on our PC, and the good news is it will be easier to install. So once we install, we can begin to build image on our PC, or of course on the cloud. We don't need to install Singularity. We can just build our image there. So once we build the image, we can upload the image to the supercomputer cluster, like upload it to the TACC, and then we run the container to use our software, or to run some simulations, or execute some code, some some task you're doing every day on the cluster. Okay, so to install the Singularity, the process is easy. So that's the good news. So I didn't add too much details about the Singularity installation. Just make sure that you know where and how to install it based on your operating system. So if you are using Linux on your PC, so that should be very easy to install Singularity. You just you use the yum install, or you can find some RPM a pre-built RPM package, and then install Singularity with the RPM. Or if you like, or you can install Singularity from the source. So just like me, so I prefer to install from source, so I know what's going on during the installation. But still, those dependencies of Singularity and are needed to be installed by yum or by RPM. So you will have so make your installation easier. If you are using Mac OS, that's another popular operating system. So you need to run some Linux virtual machines. So we are skipping this because it should be it's almost about how to run the Linux virtual machine on the Mac OS. But if you are a Windows user like me, so I'd recommend you to install a Linux platform in Windows, which is called the Windows Subsystem for Linux. Now it is in the second version of this platform, so it's called WSL2. So that's a Linux platform for the Windows user, and it's very easy to install that WSL2. And once you installed, you will have a Linux platform in your Windows, and you then just install Singularity with the yum or apt or RPM, just like you are using Linux. So that's my recommendation to install Singularity into a Windows. And once we have installed the Singularity image, Singularity software, the next step is to build an image there. So that's the next thing we need to do. And I'm showing a very simple command called Singularity build. So that command will help you to build a Singularity image from somewhere. I mean, from somewhere, because you don't create an image from nothing, right? So it has to be from somewhere. So here I listed I gave the Singularity command directly from their user menu, so which is about building a Singularity image called lolcal.sieve. So that's a Singularity image we are going to build. And in this Singularity build command, we also specify where the source of this image we are going to use. Now we can see that it's a docker and colon / and a username, and then slash the image name. So this is this docker is a place where the Singularity download the pre-built image, and then transfer the image into the Singularity format. So here the Docker :/ refers to the Docker Hub container image URI. So what is a Docker Hub? I'm going to introduce those popular places where those pre-images are saved. Okay, so Docker Hub, we just see example in the Singularity build command. So what is a Docker Hub? So Docker Hub is the most popular image repositories in the world. So it has tons of pre-built images saved there for in the Docker format. So that's why we need a Singularity build command to transfer the Docker format to the Singularity format. And you can search the container images without a Docker Hub account. So you even don't need an account. But with the account, first you can upload your own image. That's a Docker image, your own Docker image to the Docker Hub. And with the account, you might need to do some other things, but I'm not very good at Docker, so I don't use Docker Hub account quite often. I just got my Singularity image from the Docker Hub. But generally, as at least, please do not simply visit there and search images, because there are too many images there, even for the same software. So, for example, if I go to the Docker Hub here, now you see my screen is a search result of the same tools on the Docker Hub. And if I search same tools, you see how many results I got? I got 709 results for the same tools. That means hundreds of the Docker images are available for the same tools. So maybe I can try my best to guess which one is the best or which one is suitable for me. Maybe I can see when was the last date they updated their Docker image, or how many downloads they have, and some details. But I would not recommend you to just visit Docker Hub and search the tools you want. Instead, please refer to the software manual or software document, or ask the software developers for the best container images. Because if they have a Docker image or Singularity image available, usually they will upload it or save it somewhere in the Docker Hub. So that you can find such information on their software's manual. So you know which one is the best one the developer recommends. Okay, so we know as long as we know where are those where's those Docker images, we can then use the Singularity build to download the container images, and the format is listed like this. It's a URI, and then the layer one, which usually is a Docker Hub's username, and then / the layer 2, and then a colon and version tag. And I listed I've listed some examples here, and you can see that if we wish to download Ubuntu in the which has a version of the Bionic, we use this URI in our Singularity build command. And once we run the Singularity build, we can build a Singularity image from the we can build the image from the Docker Hub. Okay, the next repo I would like to recommend. It's called the NVIDIA NGC. NGC is called a NVIDIA GPU Cloud. So why I recommend this? Because this is built and managed by the NVIDIA communities. So the pre-built images here are also saved on the Docker hub, but it's a private registry. So that means you need to do something to before you can build the Singularity image from from the NVIDIA NGC. But once you make it, you will find that you will have a lot of images pre-built images available from the NVIDIA NGC, and those images are designed for you to run in the GPUs for the GPU simulations, because in those images, the NVIDIA community has already installed all those NVIDIA GPU libraries, such as the CUDA or the CUDA CNN, those libraries into that image. So all you have to do is you download the image and transfer to the Singularity format, and then you can have a very good image for you to run the to use GPU. So it provides a natural support for the GPUs, and to use them in the Singularity build command, I highlight here in the red. You will need to add this string into your Singularity Docker URI. That string is for you to use the NVIDIA NGC to use the NVIDIA NGC. And I also gave an example here. But just remember, you need to do this to have these three steps in order for you to use to set up the environment for using the downloading the images from the NVIDIA NGC on your PC. Okay, the next external resources I want to introduce is the biocontainers, because we know we have I know we have a lot of bioinformatic researchers here. So if you go to their repo, you will find a lot of pre-built Docker images about the bioinformatic tools, and you can choose the one that meet your requirement. And also it's a private, it's not a private, but also it has a special string, as I highlighted here in red, to use to use and build images from the biocontainers. Okay, so we just see several very popular repos that can be used to build the images. But Singularity can also use the build command to create images from a definition file. We usually call it a recipe. So the command example here is a Singularity build, and then the image name, and then add the recipe name. So here the recipe name I named is called Singularity.AlphaFold. So this is a recipe I built for creating an image for the AlphaFold. So that's the recipe name I want to use. And if you look if you go if you look at their the Singularity menu, you might be told that use a recipe when you wish to modify existing image, or when you want to build an image from scratch. That means the software you want to use is not available on the Docker Hub or on anywhere else. But creating an image from a recipe is strongly recommended by me. I mean, as a user, as a Singularity user, I would strongly recommend you to build your Singularity image from a recipe. Not because when you wish to modify an existing image or build an image from the scratch, but also because almost every image I found might be better to be customized for better use run on the cluster. For example, I can add some binding points and save it into the recipe, and I will talk about what is binding point later. And I can set up any necessary environment variables for running the containers. And also, using a recipe is a better record of the image building process. So it's like a single definition file. Once you open the file, you know how your Singularity image is built. So you can use it as a record of the detailed image building process. And also you can share this recipe to your colleagues. So you can let them to build their own image based on your recipe. So that's why I would recommend you use a recipe to build the image. Okay, so here is how a recipe looks like. So it's a plain text file, and in that file there are several sections. The first section defines, it's called the header file. It defines where you put those your images from. So remember the Docker URI and some layers and the tags we saw in the Singularity build command. You use that, but you just define where to get the pre-built images and what is the name of the software and the tag in the header file, and then you can let Singularity know where to look for those pre-built images. And then in the next session, you can add some labels to change the metadata of the image. And then you can use the post session to install to configure or download anything you would like to add to the Singularity image. And once the installation in the container is done, you can then use them once the image is built. And in this example, the last session is called environment. That's for you to define the environment variables that will be set at the container runtime. So you set some environment there. You can change the user environment of the container at its runtime. And there are some other very popular recipe sessions I listed here, and they will help you to make better recipes. For example, if you want to copy some files from your PC into the container during the building process, you can use the section files to copy those files. Or if you want to define the run script at the Singularity runtime, you can use the run script sessions. And if you want test your Singularity containers, you can use the add test sessions. So a simple test will be carried out at the end of the Singularity building process. Okay, so how would you like to finalize the recipes? And you haven't used this before, but I tell you that each Singularity build command may take like 10 minutes or longer, even longer, to build a moderate size container image. I'm not talking about those very simple exam, but just some real life exam. I found it might take like 10 minutes or even longer to build an image. And if you write a recipe about how to build the image, there are always some uncertainties when running the Singularity build, because once your recipe is done, you don't know whether those commands in the recipe can work or not. And once it's not, so the building process will be terminated immediately by the error. So that means they take like 10 minutes for the Singularity to build the container, and then the container finally runs some command in the recipe, and one of the command gives you some error, so that the build process is end. So you will need to debug what's going wrong, and then you fix that line and then rerun it. If that's your workflow, you will find that that's not a good idea. So even you're trying to make every command in the recipe running, you try your best. There are always something that you didn't expect. You will be very mad that you found a simple error that you didn't expect during the building process, and then you have to start over. So I based on my experience, I just recommend a workflow to finalize the recipe. So first, you choose a very base container as your starting point, and then you create a Singularity sandbox with the image that has the base desired tools. You just add an option --sandbox to make a sandbox. And what is a sandbox? Sandbox is a container within a writable directory. So that sandbox you can write is writable. So that means you can get into the sandbox and write everything, add everything into that sandbox. And once the sandbox is created, you can then end the sandbox with the Singularity shell command. You need to add the --writable, and then test with the interactive commands. And once you are in the sandbox, now you can type or enter the command you want to use and enter it here. And since it's a writable sandbox, what you write and what you install here will be applied, I mean, in this sandbox. And you will say that whether the installation is successful or not. So if the command works, you can then add that command into your recipe. Or if not, it doesn't work, you can just make some corrections about based on the error message on your screen, and you can do this until you finish all of the commands you want to add to the recipes. And finally, you can build another image with the final recipes. Okay, here is some visualized, I hope it's a visualized example how to finalize that recipe. So first, you will have a very simple recipe here, but the commands you want to test is empty. So there's nothing under the post section of this recipe. You first create a sandbox and then enter a sandbox, and you begin to test those commands you want to use. For example, I want to test if I can install the GCC 9 in the container. If this works, I will see it has been installed. I can see the results on my screen, and then I just add this command into my recipe under the post session. But if a command doesn't work, for example, the next command I want to use is called install G+++. I had a typo here, maybe some other kind of error I didn't notice. Then on the screen I see oh, that command doesn't work. I should not add it to the recipe. I need to correct it. And once I make the correction and make sure this command works, I then add the correct command into the recipe. So that's how the recipe build works. So I will have my final recipe that will be used for the image building. Okay, so once we have the image, then we just upload it to our clusters, and the Singularity is already installed on our clusters like the TACC expands, and on TACC is available on the compute nodes by default. So there's no need to load the Singularity module. But just note Singularity is not available on the TACC login nodes. Why? Because we don't want any Singularity running on the login nodes. Please always start a job and then run Singularity. It can be an interactive job, or you can add the Singularity command in your job script to start a batch job. And we also have some container locations on our clusters where we have some where we have some Singularity images available system-wide. So for example, on TACC, I think it's in our projects builder group Singularity. If you list the files, you'll find some images already there. And we have many other images available on the TACC. Some of them you even might not notice it. For example, the Mathematica on TACC is now actually running in the Singularity container, but our users just use the math command, so they might not notice that it's actually in a container. So there, if you go to the cluster, maybe you will find some examples there, as well as the recipe example. So for example, this is my recipe for building a RStudio image on my PC. Actually, I cannot build the images on the clusters. So here are just some examples I saved there. Okay, so to run Singularities, there are several ways to run Singularity on the clusters. If you want to have some interactions with the images, you can use the Singularity shell command, which we saw this when building and finalizing our recipe. So on the cluster, you can also use the Singularity shell command to start an interactive shell. And once it started, you will find the command prompt has changed to the Singularity and the arrow sign, and then you are inside a Singularity shell. Yeah, just know you don't need a sudo permission to run Singularity on cluster. You are free to run it. And we will find that we can access some file systems, some native file systems, but actually we are inside a inside the container. So the file system container, the container's file system is different from the original file systems, and I will explain this in detail later when talking about the binding point. Okay, the next way to run the Singularity container is use the Singularity run. This Singularity run command can run the container using a predefined command. So here is an example. I run the Singularity run cal.cif. It will run a certain predefined command inside the image and then give me the results. And this running command can be defined in the run script section in the recipe. So if you wish to define some command that is available to Singularity run, you can add a session in your recipe. Okay, the most popular way to run Singularity container is through the Singularity exec. We use this a lot because it can execute a customer command within a container, as long as that command is in the path in the container. So here is just a simple example to show we want to run the Python command, and for Python command for our Python script, and we use exec command and tell them which image to tell Singularity which image to use and which command to use, and if there are any arguments or options for this command. So all three ways, shell, run, and exec, are very easy and simple, easy to understand. And what I want to add more is about the binding point. So the original file system and the container file system are not the same, because from the Linux structure, we know that we are in another file systems when using the containers, but they are sharing the home directory for each user, but all other file system directories are different. That means native file system has its own bin user lib, and also the native file system has the projects directory and the OSIS directory on our cluster. But usually those two directories are not available on in the containers file systems. And also some commands, usable commands such as the NVIDIA-SMI doesn't exist in the container file systems. So if we want to use Singularity and to access our projects directory or to access our OSIS directory, what we should do? So that's how why we need the binding point. So we can create a binding point. In this example, create a binding point when building a Singularity image. This can be done in the post section in the recipe, and here I make two directories in the container. And later, at the container runtime, I can add an option --bind to bind those directories. And here is an example. It's like the -b. Like I want to bind the OSIS directory, and I also want to bind the project directory when I'm running the image. So once it's running, the Singularity can find my project and OSIS directory. So if I want to add a binding point for a file, I can create a file having the same name and the location during the binding process. For example, I can add the NVIDIA SMI in when building the Singularity image, and then during the at the container runtime, this command will be available to me. So I don't need to add the binding option for a file, but as long as I already created at the same place in my during the container building process, I can use that command at the container runtime. And I also list some other useful binding points right here, and those binding points are optional, but I think they are useful. So if you like take a look after this training, and also you may notice that if you run a Singularity command, you have to type a very long command. If you want adding those binding options and any other options you like, you can just make a simple script. Here, I use my colleague's example, and a simple script, and tells the Linux this is a bash script, and then add the long command into that script. And at the runtime, I can just run the script as usual, and with any options and the arguments I want. And here I would also like to mention that the --NV is an option enabling the NVIDIA GPU support. Especially if you build your image from the NVIDIA NGC, you will find this option is very helpful, and the container images can run with the GPUs available on the TACC very easily. Okay, last, I would like to mention something that some of you might heard that the Singularity open source project was named to the AppTenor, like I heard, but we still call the Singularity because the Singularity family still exists. So this is this is some history story. So I am not going to teach history here, but just want you guys to know that even the name has changed, there will be no effect on our current SC clusters, including there's nothing changed on the TACC. We still use the same Singularity command because we have Singularity Pro version installed. And also, even in the future, if the AppTenor and Singularity AppTenor is available on the cluster, you can still refer to this today's training session to learn how to AppTenor, because it's almost the same at the user level, especially those base stuff and the base concept and ideas of the container. And of course, if other clusters are using AppTenor now, you will need to confirm with their HPC admin staff to say if they are using Singularity or the AppTenor. Okay, so what we have learned today. So first, we learned why we need to use singularities on clusters. We needed to facilitate our software installation. We needed to share our software and share our test process with our colleagues so they can reproduce our results very easily. And how we made it. So we then learned what is a container and what is a Singularity container, and why we use Singularity rather than Docker, and how can we build the image from some download some pre-built image from some popular repos and then build it with the recipe. And I also introduced some recommended workflow about how to build our image. And last, we spent a few minutes to learn how to run Singularity container on the clusters. So which is quite easy and straightforward. So I didn't use too much time to introduce how to run it on cluster. So that's all I want to share today. And as you may know, the TACC is managing hundreds of compute nodes and a software stack. And if you have any questions, feel free to let me know. And here we also have a new website name, so which is the treatingcluster.sdsc.edu. So if you like, you can find lots of useful information on our website. So thank you, everyone. So that's all I want to share today. And any questions or comments?